Is this low-cost quarter-wave vertical worth it? You can order this from anywhere from $25 to, I've heard, over $100. You can get it direct from China, you can find it on eBay, or you can even get it on Amazon.com. Let's take a look at it next on AA3K On The Go. So, a little while ago, I decided to take a risk and order one of these low-cost quarter-wave vertical antennas off of AliExpress, and it was shipped direct from China and transferred over to the US Postal Service, and it arrived in fine condition and such, and I've decided to finally give it a shot. And the only thing I really had to figure out is where the antenna goes and where the ground spike goes, because it's no indication as to what end is connected to one end of the SO239 here. So I have finally set this up in the AA3K antenna range, better known as my backyard, with my Rig Expert AA55 and a laptop to record screen captures from the AA55 and give this a test to see how well it loads up on 2017, 15, 12, and 10 meters, plus 6 meters. And the end result was, as you shall see, not too bad, not perfect, especially as we were getting up in frequencies, a little bit squirrely, I would say, on a couple of the bands, and you'll see when we review those SWR curves in detail, but definitely usable for portable operations. Without much further delay, let's take a look at the SWR curves that I captured. And before we get there, why don't you take a moment, subscribe to the channel. Your subscription will really help the growth of this channel. All right, let's take a look at what came as a result of my order of this antenna from AliExpress. It came in this cardboard box, which was in a plastic bag overwrap with the shipping label on it and such. And it was shipped from China, transferred over to the United States Postal Service, and made it to my front door in about a week and a half, 2 weeks. I really wasn't keeping track. No significant damage to the box, but the box itself, was just in the bag. Let's take a look at the label here. And it states it's 5.6 meters, 18.3 feet long. Now, I have actually measured the width. It comes out to be exactly 17 feet long. It does say it's a QRP antenna, 14 megahertz. It probably means to 30 megahertz, 300 watts to 600 watts, which is not QRP. Antenna stainless steel, 1/4 wavelength for micro SDX QRP radio. Well, there's really no reason why this antenna will not work at QRP levels and will work at least 100 watts, possibly all the way up to 600 watts. There might be some concern at a certain point for arc over between the actual RF signal and ground, but no reason that you can't use this at 100 watts. In the box, let's just get it all into frame here as best as I can. As you can see, I've opened it already. We do have the counterpoise, and I will measure this separately and let you know. And it's just computer ribbon cable, and you separate these into the individual radio lengths. I really don't know how long this will last. I have seen ribbon cable being used in a portable setup that was moved frequently, and all the individual strands were starting to separate. Ribbon cable is just not designed for continued flexing and reflexing of a significant amount. And by the way, there are no instructions in the box, just there is some extra end padding at the box so the items don't slide through and punch out the back of it. There is a ring terminal to connect this to where the ground spike goes, to put this into the ground and support it, which is, I think, the one downside to this antenna. I live in Pennsylvania, and I've spoken with Pennsylvania park staff and rangers, and they are very, very accepting of amateur radio in the parks. And as long as you don't damage any areas that are marked as particularly sensitive or closed, and don't leave ropes and trees and such, they're really quite supportive, and they wouldn't be so or I should say, they wouldn't be too complaining of you sticking a spike into the ground. Other parks, national parks, well, it's a different story. The thread on the end of this spike is, well, let me get that in the right spot there, is 9.83 millimeters. So, you know, not the standard 3/8 inch of most other antenna mounts. You have the center insulator, a little bit dirty there. I may clean that up. And unfortunately, it does not indicate which side is for the antenna and which side is for the spike. But I do have my handy dandy multimeter, and we're hams. We can figure it out. And just a quick continuity test between center conductor and which is the radiating end and which is the ground end. And we'll do that in a few moments. And then finally, you have the collapsible whip antenna. And this does seem to be pretty well made. I have previously extended it, and it is 17 feet long from here at the base of the antenna, not counting the thread, all the way up to the tip when fully extended. It feels solid enough. You know, the tip is going to be just a little bit wobbly when it's up there, but we can, you know, as long as you're not using this in the middle of a hurricane or any other high winds, you should be in pretty good shape. And again, we're going to check the size of the base here, and that's coming out at 9.93, just a tiny bit bigger. But that is brass, and this is brass, this is stainless steel. And, you know, and maybe actually that's how you tell which side goes in which. It may be keyed that you can't put it in. Well, that screws in just fine that way. And it screws in just fine that way. So it's kind of like we're gonna need to pull out the ohm meter. We'll do a quick check with this. That's screwing in just fine there. And this is screwing in just fine here. So let's get the ohm meter out, and probably a Sharpie to mark which end is the antenna and which end is the ground spike. I have a nice fluke meter here. It's in continuity mode. I'm gonna put this, hold this to the ground there carefully. 3 hands. That seems to be ground and nothing there. Stick that on the center. That's antenna, that is ground. So I'm gonna put this down here and double check that I haven't mixed things up. And nothing on the bottom. So this is the antenna side. So I'm gonna grab a Sharpie, excuse me a moment, and we'll write that down so we have it for future reference. All right, we've got a Sharpie. Just for giggles, we'll give one last test here to make sure we don't get our sides confused up. That's the antenna. Sorry about that. And we're going to do this off camera because it's actually very hard to do coordinated things while looking through the camera viewfinder. And there we go. I wrote ANT on it twice in case one gets wiped off, and we'll check it later. This is a very dense plastic. I don't know if it's Delrin and such. I have heard some of these insulators that you'll see a little tab at the bottom, which is what the ground strap to the bottom threads is connected to. This does not have that, so it's, you know, you cannot tell the difference one way to the other. All right, let's take this outside, set it up, and see how it goes. All right, let's look at setting this antenna up. And one thing that we should do is separate the strands of this ribbon cable. There are actually 10 strands here, and they'll become the counterpoise. As I said, I forgot to measure these. I will measure these separately. Let's just do a quick guesstimate here. though I'm kind of terrible at estimating distances or lengths. I'm gonna say that's probably 12, 15 feet, maybe 3, 4 meters less than the whip. I may make some new counterpoises similar to what I use with my center loaded vertical. These are 33 feet and there's 4 individual legs made out of speaker wire. Would not be hard. I have plenty of speaker wire hanging around. And if I don't have a ring terminal of that size, I'm sure I can find one and quickly make a new set of radials up. After I separate all of these, it's going to be a little bit difficult to store them. I think I'm going to save a toilet paper tube and use that to wrap all of these around there. So let's start getting these separated. And we're not going to bore you on camera with this. Needless to say, it does take a few minutes, but this is a one-shot deal. You only will need to do this the first time. And again, as long as the radials physically hold up, they should be fine. Using the 16 gauge or so speaker wire there, that's definitely a little bit, will last a little bit longer through use. I do have some concerns. UV light on these radials, will it eat up the vinyl coating or whatever the plastic coating is on the ribbon cable wires? And that last one separated is turning into a real, there we go, pain. So I'll separate these all separately and then we'll show you setting up the antenna as a whole. By the way, as I was mentioning about UV light, and this antenna is definitely not meant to be sitting out for months on end. Will it attack this vinyl? I know it will attack this clear vinyl and the speaker wire, but this antenna usually does not sit out, worst case, more than 2 or 3 days, and usually only a couple of hours. Okay, there we go. We have all of the strands separated and you can see it is already a spaghetti mess. I'm just going to try to lay them out in a even pattern here before I punch the spike in the ground. Matter of fact, why don't I do that first? So we'll get the spike. As you can see, I did right which is the antenna side. I'm going to just put this in here for now. And fortunately we had a whole bunch of rain the other day, so my ground should be pretty soft. I don't know how strong the insulator is to put a full bit of weight on it. Definitely don't want to pound on it, but that seems sufficient. And you don't want to use a hammer on the thread ends, because that can definitely damage the threads and then you don't have a usable spike anymore. Okay, let's find the, there it is. Everything comes together in a giant mess. Let's just kind of pull this all together here. Throw that way. Just throw that on there. Screw it down. There we go. And just for the immediate giggles, we'll throw the telescoping whip in. And now let's straighten out these wires and start laying them out in a circular pattern. And the idea of coiling or rolling all of these wires up onto some sort of tube or something is probably a real good idea. And they will, no matter what you do, they will get tangled. So setting this antenna up might take a few extra minutes than what you anticipate. What I'm just going to try to do is evenly divide into 2 groups of 5. 2, 3, 4, 5, and separate them this way. And then I'll basically use like a computer algorithm binary search And just keep dividing into groups of 2. And you see they're already tangled here. And I'll probably speed this segment up so I don't have to bore you with all the challenges I'm facing at this moment. It'll be good to simply divide the 10 conductors in half, 5 in one direction, 5 in the other direction, and then you can start spreading them out evenly. The more radials you have, generally the better. The 4 radials that I typically use with my center-loaded vertical have performed extremely well, and I would only expect better performance from the antenna if I was to add additional radials, but then that does create more work putting them out. Well, got my step count there. That's a reasonable pattern. I might want to adjust a wire or 2 to make it a little bit more evenly spread, but we're amateur radio operators. If we're making contacts, we're happy. All right, let's extend the whip, get the coax and choke, connect to my rig expert, which will be hooked into the computer so I can capture screenshots of the SWR sweeps, and we'll take a look at this. The lowest frequency, or the lowest band of operation will be 20 meters. Maybe with a tuner I can get it to 40 meters. Don't know if we'll try that, maybe at another date. But then since the whip is adjustable, you can get this, should be able to have this thing tune any frequency between 6 meters and 20 meters. Even the CB band if you want. So as we look at the initial sweep, we see that the telescopic whip is just too long. And to adjust, we're just going to start lowering it down until we find a match that is good for the radio. And you can then take the whip off, measure it, write that down, and bring a tape measure with you when you set up, and then repeat that setting in the field. And you only have to tweak a little bit for local conditions, particularly ground conductivity, which will throw things off a little bit. Not necessarily throw things off, but change things a little bit from what you have. And there's probably a certain amount of grounding that the spike is naturally providing. But this is Pennsylvania, lots and lots of rocks in the soil. And at best, we have only average ground conductivity, not like being at the beach with a saltwater ground plane to really improve your antenna's performance. All right, now that I've lowered the antenna, let's take a quick look at see where the SWR falls and make any further adjustments. All right, let's take a look at the SWR curves. We have an excellent match, 1.2 to 1 or less on 20 meters, almost 1.0 across the band on 17 meters. But then things got interesting on 15 meters. We're about 1.7 across the band. The lowest 1.62 to 1 at 21.1 megahertz, and 12 meters is about 1.5 across the band. 10 meters is very high. 1.76 is the minimum at way high in the band, 29.5 megahertz roughly, but closer to 2 as you get into lower frequencies. And then 6 meters becomes usable, about 1.5 to 1 across the band also. And I'm trying to understand, and have not yet determined, what caused those funny readings. And thinking about it, I had the antenna set up very close to my sunroom, which has one foil-backed insulation for its vapor barrier. and a very nice metal gutter across the end of the sunroom that's closest to the backyard. And many years ago, I was tuning a Cushcraft R7 vertical antenna that I had lashed to the back of my backyard deck at the house that I owned at that time. And it was not tuning up anywhere according to the given measurements. And as I'm out staring at the antenna, I noticed across the back of my house was a metal gutter. And I surmised that that detuned the antenna, and when I moved the antenna further away from the house, it tuned up exactly where it was supposed to be at the given measurements from Cushcraft. So I'm going to be rerunning these tests in the future in a much more open location. I have not decided where yet, and I'll give you an update on these tuning charts. That won't take too long to do. Fundamentally, the antenna is a quarter wave vertical. There's really no magic in there. There's no loading coils, there's no traps, there's no additional capacitance. So it should just work once set to the length of the desired frequency of operation. And if we go forward with this, we have the measurements of the radiator that I wrote down for each of these bands. And feel free to stop the video and write this down or get a screenshot. And you can use these as starting points to tweak the antenna for each of these operations. And if I get decidedly different numbers when I rerun these tests in a more open area, I'm going to present any updates to these numbers. Do I consider this antenna still to be usable? Yes, I do. Even with those somewhat high SWRs, if you have an antenna matching unit either built into your radio or separate, you can tweak the SWR down to levels that'll make the radio happy for operation. Oh, there we go. Is this a usable antenna? I'm going to say absolutely so. You know, the only real downsides to this antenna are the whip itself seems a little bit lightweight, say, as compared to the MFJ 1979 whip. If you can find one of these, I get a hold of one just so you can have it in case you ever really do want to use it. Though this does have the at least American or North American standard 3/8" base, but this seems to have the Chinese 10mm common base. But you can find an adapter, make an adapter if you happen to have access to machining equipment. The other downside I see to this antenna, well, there's actually two downsides, is the spike that goes into the ground. There are some places, parks and such, that really don't want you poking holes in the ground. I really like to know how they prevent animals from digging holes in the ground, but that's a separate discussion. So if you're going to fly with this base, you're going to have to put it in your checked luggage. It's not going to get through the Transportation Security Administration in the United States or any other security agency for airlines. Overall, it's pretty lightweight if you're going to hike in for a QRP activation. So that's a plus on the plus side. But the downside is those radials. They are very, very thin. As a matter of fact, when I was pulling the base out of the ground, I accidentally was kneeling on one of the radials, and when I put tension on it, it snapped about 2 or 3 inches down from the ring terminal. Now, I can solder it together, cover it with a little bit of heat shrink insulation, and it'll be just fine for a 10th radial. As a matter of fact, I can even leave it off. It probably won't make much of a difference to have 9 radials as compared to 10 radials. But definitely on the delicate side. And those 10 thin wires are going to get tangled no matter how neatly I roll them up. But I'm going to get my hands on a toilet paper roll, paper towel roll, something like that, that I can at least neatly roll them up so they don't become a big tangled snarl in the box I intend to carry all this in. So I'm going to leave some links down below in the description to hopefully, if I can find it again, where I actually purchased this through on AliExpress. Should be recorded there. But any other links I can find there, Temu, Banggood, Amazon, eBay and such, it's available from a number of different places. It's well worth it if you can buy this around $35 or so. The latest tariffs might push the price up a little bit higher, but there's no magic to this antenna. It is a quarter wave antenna. You can get it to work, you know, from 20 meters on any frequency above there. You know, and while I did have some squirrely tuning results on bands that I didn't expect, there is a difference in performance of radiators as you go thinner and thinner. So I kept collapsing it downward, so the thicker radials ended up here in the base. I might try the other way and keep the thicker radials exposed and collapse down the thinner radials, and that might improve the performance of the antenna. Something to experiment for next time. Oh, and one last thing is when you're pushing these down, you kind of feel them hit a detent point where they push in another centimeter or two. Either do push them through that detent or don't. Just take that into account in the length of your antenna and set it up consistently when you want a repeatable performance on different bands. Hey, thank you for watching. This is Mark, AA3K. Why don't you like, share, subscribe? And if you have one of these antennas or have any comments or questions about it, why don't you go ahead and put it in the comments section below. We can continue any discussions down there. 73, and I'll catch you the next time.